Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is lesson 3-9 for Algebra 1. In this section we'll be studying the Pythagorean Theorem. Our objectives are to solve problems using the Pythagorean Theorem and to use that to identify right triangles as well. Okay, so key concepts here. The Pythagorean Theorem itself tells us that in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So you may recall this as being a squared plus b squared equals c squared. A and b are the legs, c is the hypotenuse. The converse of the Pythagorean theorem tells us that if a triangle has sides of lengths a, b, and c, and a squared plus b squared equals c squared, then the triangle is a right triangle with a hypotenuse of length c. Okay, let's also go and look at a couple of definitions here, a review of things that go with the Pythagorean theorem, and then conditions, a conditional, etc. Okay, a hypotenuse is the side opposite the right angle in a right triangle. It is the longest side in the triangle. Okay. So if you look in the diagram above, C is clearly the hypotenuse. It is longer than either of the other two sides. The legs are the sides that form the right angle in a right triangle. Okay, so those then by definition are going to be the shorter sides as well. You see side A and side B meet, and well, they intersect and form a right angle. So A and B are the legs of the triangle. We'll also be looking at conditionals. A conditional is an if-then statement. The converse of the Pythagorean theorem is a conditional, for an example. Okay. A hypotenuse is the part, I'm sorry, I said hypotenuse, and I didn't say hypothesis, which is what I'm trying to define here. My apologies. A hypothesis is the part following if in a conditional. A conclusion is the part following then in a conditional. And finally, a converse is the statement obtained by reversing the if and then parts of a conditional. Okay, so what that might be, if we apply it back to the converse of the Pythagorean theorem, the triangle is a right triangle with a hypotenuse of length c if the triangle is a right triangle with a hypotenuse of length c, then it has sides of lengths a, b, and c, where a squared plus b squared equals c squared. Okay, so it's just flip-flopping the hypothesis and the conclusion, or the if and then parts of a conditional. Okay. All right, let's see here. And let's look at this. Using the Pythagorean theorem. What is the length of the hypotenuse of this triangle? Okay, so this is a fairly straightforward application. We have a right triangle here, legs of 8 and 15. So a squared, which in this case we'll call 8, and 15 for b. 8 squared plus 15 squared equals c squared. So 64 plus 225 is equal to c squared. The sum of 64 and 225 is 289. So if I take the square root of 289 and the square root of c, and the principal square root, meaning we want the positive square root, 17 is equal to c. So the length of the hypotenuse is 17 meters. All right. Next example. Using the converse of the Pythagorean theorem. Determine whether the given lengths are sides of a right triangle. Okay, so if we have 5 inches, 5 inches, and 7 inches. So determine whether, we're trying to decide whether a squared plus b squared equals c squared, where c is the longest side. So 5 squared plus 5 squared, does that equal 7 squared? So 5 squared is 25, plus 25 again. We want to know, does that equal 49? Okay, 50 does not equal 49. So this triangle is not a right triangle. Okay, so the next conditional is, we're trying to find out if the converse is true here. 10 centimeters, 24 centimeters, and 26 centimeters. So if 10 squared plus 24 squared, we're trying to determine, does that equal 26 squared? So 10 squared is 100, 24 squared is 576, and 26 squared is 676. Okay, since 676 equals 676, the triangle is a right triangle. Okay. Okay, and let's look here. This is an application of physics. If two forces pull at right angles to each other, the resultant force is represented as the diagonal of a rectangle, as shown in the diagram. Okay, so we have force A pulling at force B, okay, at right angles. The resultant force would be this diagonal. Okay, so the diagonal forms a right triangle with two of the perpendicular sides of the rectangle. Okay, so basically for a 50-pound force of A, so that would be A squared, and a 120-pound force, B squared, we're trying to determine, does that equal the resultant force of 130 pounds squared? Okay, so we're going to try to find out if A squared plus B squared equals C squared, where C is the greater of the forces, or the resultant force. Okay, 50 squared is 2,500. 120 squared is 14,400. And 130 squared is 16,900. Okay, the sum of these, 16,900, is equal to 16,900. So the forces of 50 pounds and 120 pounds are pulling at right angles to each other. Okay. All right. That's it for our notes for this section. You have 3 quick checks to do. Please have these completed. Bring in any questions you might have. And again, you may refer to the textbook if you would like to read up a little bit more on this information or look at different examples. I look forward to seeing you in class. Bye now.